Welcome to clickmyproject.com. Now we discuss about the product for Parasitics-Aware design of symmetric and asymmetric gate work function FinFET SRAMs. Next we see the abstract for the product. SRAM is a form of semiconductor memory widely used in electronics and microprocessor and general computing applications. This form of semiconductor memory gained its name from the fact that data is held in a static function and does not need be dynamically updated as in the case of DRAM memory, while the data in the SRAM memory does not need refreshed dynamically. It's still volatile, meaning that when the power is removed from the memory device, the data is not held and will disappear. The operation of the SRAM memory cell is relatively straightforward. When the cell is selected, the value of to be returned is stored in the cross-coupled flip-flops. The cells are arranged in a matrix with each cell individually addressable. Most SRAM memories select an entire row of cells at a time and read out of content at all the cells in the row along the column line. Access the SRAM memory cell is enabled by the word line. The control to access control transistor which control whether the cell should be connected in the bit lines. These two lines are used to transfer the data both read and writing process and write operation. The most commonly used SRAM type of in the 60 SRAM, which offers better electronic performance from the all aspects: speed, noise and immunity, standby current. The smallest 60 SRAM cell has been fabricated till today as an area of 0.08 micrometer square and was fabricated in 20 nanometer technology based on our proposed designs. In this paper, a new approach towards the design of memristor based non-volatile static random memory access cell using the combination of memristor and metal oxide semiconductor devices proposed. Memristor and MOSFETs of the Taiwan Semiconductor Manufacturing based on 180 nanometer technology are used in the form of single cell. The predicted area of these cells is significantly less and the average of read-write operation power less than 25 times of less than the conventional 60 SRAM based designs in our overall memory architecture. The non-volatile characteristics of cell makes it attractive for non-volatile random access memory architecture designs. Next we see the flow diagram for the product. First we design the SRAM architecture designs and to apply the memory architecture design. This SRAM design does storage for the single bit storage cell for the two inverting cross connections results, and to apply the multi-threshold swapped MOS designs to optimize the number of transistor level, and to designs for the STT-MRAM architecture results. The STT-MRAM architecture is mainly used to cache architecture to design the fast temporary storage purpose using the STT-MRAM cache architecture. This result to this architecture to reduce the writing time and to reduce the writing leakage power for the overall read and writing operation for memory, any type of memory architecture results, and to design the low power consumption due to the write operation, and to calculate the final timing results for read and writing operations. These designs to optimize the SRAM based architecture results and to optimize the STT-MRAM architecture. This STT-MRAM architecture mainly consider for the data storage block, transmission gating blocks, and the sense amplifying results and the read and writing operation. Then the sense amplifier, when the data storage is internally applied for your architecture and to optimize the writing processing time and to enable the read operations to reading the operation. This the VDD storage to be optimized for our the overall architecture process and to achieve the STT-MRAM cache application results for the overall architecturing functions. Finally, we see the output for the product. This is our design for SRAM based architecture designs. This architecture mainly consider for the STT-MRAM overall architecture functions. These architecture functions to be using the full and full mux and CMOS logics for the PMOS and NMOS combinations for the overall architecture results. These functions to be applied for the data storage element, thus the data storage to be stored by the flip-flop architectures, and the enabling connectivity to be activation for enabling the read and writing process, thus the data storage to be applied for writing sections, and whenever the writing section to be activation to read the output data for due to the data storage elements. These data storage elements to be get the output results and to read the final output data results. These are the architecture designs for overall STT-MRAM cache architecture results. The sense amplifying results to be amplify the final data output results due to the STT-MRAM architecture results. This is a non-volatile purpose and to satisfy the non-volatile architecture for SRAM designs process. This is our final results for our timing diagram for required STT-MRAM architecture designs. This is one of the application of STT-MRAM architecture design. Thus the timing diagram for overall final architecture output process. This is the final output timing diagram for our required results for read and writing operation, and to write the clocking function to write the data for final output results for our the due to the timing diagram results for our the architecture results. This is our the output for our the read and writing operation architecture results for overall STT-MRAM architecture designs.